Okay, let's get started. Hopefully you're here for CS 140. If not, you can find another classroom where you can stay and enjoy. I'm Brad Vander Zanden, and I'll be your instructor for the semester. You've met your lab TAs already, hopefully, having come to lab yesterday. And I don't think Alan is, there's Alan. So for those of you who have not met Alan, from Casey's section, he will be assisting with the lecture sections. And the reason he'll be doing that, for those of you who had me for 102, you know that I favor something called a flipped classroom. And we'll be doing that to a certain extent here in CS 140 as well. So if you're wondering what is a flipped classroom is where I expect you to come to class having already done some preparation. In CS 102, I posted video lectures. In this class, there are a set of notes that have been prepared by another professor, Dr. Plank, whom you will all meet next fall in CS 302. And in order to keep the sequence well aligned, I'm using his notes this semester, as well as the fact that he writes a fantastic set of notes. I will expect you to come to class having read those notes. Now, they don't take a lot of time typically to read, so this isn't a severe imposition on your time. Then in class, we will be doing a mixture of things. Sometimes I'll be going over some of the key points in the notes or expanding upon them. Sometimes I'll be giving demos. Sometimes I'll be having you take stuff from the notes and work on it interactively, oftentimes in groups. I have found that the flipped classroom helps keep people's attention much better. So I don't know how many of you know, we'll see if anyone wants to take a guess. What is the average attention span for an adult, roughly? Yes? Well, 30 minutes. 30 minutes for you? 15 minutes. 20 is the generally accepted number, and that was before the advent of mobile devices when these studies were done. So there's a good chance that 20 minutes is an optimistic estimate at this point. But what that means is, even at the best of times, an average person can listen to me for about 20 minutes. And if I'm really entertaining, maybe I can hold your attention a bit longer. But even if I'm entertaining, the problem is your attention flags. It can come back with a little bit of a break. But that's only part of the problem. The other part of the problem is you really don't learn material unless you practice it. Okay, my favorite example is golfing. I'm a golfer. And I know that I could watch any number of videos showing me the right way to swing a golf club. And it could be done flawlessly. But until I do it myself and until I have someone sitting there fine-tuning it, I'm not going to learn how to swing a club. Same thing with riding a bike. Okay? You can watch someone do it all day. Until you've done it yourself, you're not going to know how to do it. Where my value comes in is not in regurgitating something that you can read in notes. Okay? My value comes in being able to help you when you have problems. And so a few years ago, I went to this thing of having you prepare before class, expecting you to come to class prepared, and then doing things like hands-on exercises in class or expanding on things. My letter grades went up by 2/3 of a letter grade, so it works. Okay? The other thing is I find that students are more attentive in class. Okay? It also means in this class that there's a good chance I'll call on you. I'm going to be bringing roster with me to class, so you have to be prepared to be called on. Okay? You don't have to necessarily know the answer, but expect you to give it a try. But again, that means you need to come to class prepared. And it means you need to read the lecture notes before you come to class. Okay? So, that said, let's go through the kind of organization of the class, what it's about, and we may have time to just do a little introductory stuff at the end. So basically what this class is about, you can see it down here at the bottom of our screen, is we want you to start becoming self-sufficient C++ programmers. In 102, you kind of learned the basics about C++, but you're kind of scrambling from week to week just to learn the syntax. Now's your chance to practice it in this class, to really get the repetitions, to become just comfortable using it like it's in muscle memory. The second thing is to understand basic data structures. In 102, we were teaching you how to program, the basic control constructs of the language and some basic data structures. In this course, we start to talk about how to organize data. So 102 is more about control structures, and 140 is more about organizing complicated sets of data so that you can easily search it, easily process it. Okay, you had a little taste of that in 102 with searching and sorting, but it was at a very basic level. Well, in this course, we plumbed that in a lot greater detail. So the data structures we're looking at in this course are basic data structures that allow you to organize data, allow you to search it efficiently, allow you to retrieve information efficiently, and that for some other applications allow you to manipulate it easily. Okay, the third goal of this class is to teach you something about basic algorithm analysis. So here you're going to be looking at often different ways to solve a problem. Again, in 102, toward the end, we did that with searching and sorting. If you remember with searching, we had two algorithms. One was linear search, where you searched through an array linearly, and you had to look at all the elements potentially in order to find a piece of data. And then we went over binary search. And that started by looking at the middle element of the array, and at each point it eliminated half the array. And if you remember, that looked at only log 2n elements. That was a lot more efficient for finding an element in an array. Well, someone had to go through and analyze that algorithm to figure out how much time it took. So when we talk about algorithm analysis, we're talking about how fast or how much time your program is expected to take on a set of data. And typically we talk about the size of the data as determining how fast the program runs, because intuitively the more data you have, the longer it's going to take for your program to run. So typically we talk about the running time of a program as a function of the size of the data. So we'll be starting to look at that. In 302, which is the follow-on course to this one, you will be looking in even more detail at algorithm analysis. Also, just out of curiosity, show of hands, how many are taking 311 this semester? Okay, a few of you. So 311, which is discrete structures, is also concerned with, in part, giving you the mathematical background required to do algorithm analysis. So in this course, we're not really going to get into heavy-duty math. In 302, they will get more into heavy-duty math because they expect by that time that you've started to take 311. Okay? And 311, like I said, gives you many of the mathematical tools that you need for doing algorithm analysis, for constructing the mathematical functions that describe how quickly a program runs, and also for proving that that is in fact the correct running time. And finally, the fourth goal, which you started on in lab yesterday, is to become familiar with using command line tools. So in 102, we had you use an integrated development environment, CodeLite. And in fact, in industry, many of you will go back to using integrated development environments because they are very good for coordinating large projects. However, for many smaller type projects, such as the ones you do in your courses here at UT, or if you become a researcher, or if you're just at a smaller company, it is often much faster if you can use these so-called command line tools. And what I mean by command line tools is where you have a terminal window. So yesterday in lab, you were introduced to the terminal window. And so if you remember, it looks something like that. And you're also being introduced this semester to an operating system called Unix, which is different than the one that you're probably familiar with. Most of you are familiar with either Windows or Macs. Now, if you're using a Macintosh, Macintosh is actually built on a Unix variant. In the labs, we're also using a Unix variant called Linux. Okay, so you'll often hear me talk about Unix when, in fact, in the labs you're using Linux, but Linux is simply a variant of Unix. Okay? Unix is an operating system that was designed for using command line tools. And the advantage of using command line tools is that they use something called recall memory rather than recognition memory. So with Code Light, all you had to do was be able to recognize a command. You could go to, you didn't have to remember how to compile the exact command for compiling a program. You would just go to the, say, build run menu, find the command there, which you only had to recognize, and select it. Okay? In this class, what's going to happen is you're going to have to memorize the command that you use for compiling, which happens to be G++. Well, that involves using recall memory. Okay? Recall memory is where you actually have to be able to pull something out of memory. You have to be able to recall it. You can't just recognize it. But the advantage of recall memory is it's much faster. Okay? It is much faster for me to write G++, say, food.cpp than it is for me to go on a menu and start looking for the build command and click it. Okay? We started teaching you yesterday VI. Okay? It is often much faster to just be able to type things in and use commands like I for insert or S for search than to have to use menu commands. Now, I know that integrated development environments provide keyboard shortcuts. Okay? But even those tend to be clunkier than using command line tools, because with command line tools you never have to take your fingers off the keyboard. With a mouse-based system, you're constantly having to take your hand off the keyboard, put it on a mouse, then you're having to move the mouse to the right location on the screen, or you're having to find a menu. All these things take you off task. Okay? They force you to do a brain shift, and research shows that the time required to do that and then get back to your task can be up to 15 seconds of wasted time. Whereas when you keep your hands on the keyboard and are simply using command-based tools and all of your commands come from the keyboard, you're not having this interruption in your flow of thinking. So command line tools can really improve your productivity. Okay, I was a big enthusiastic supporter of going to integrated development environments in the introductory course. I think that helps ease you into programming. It may therefore surprise many of you who had me that I hate integrated development environments. For me, they really get in the way of my programming. I love command line tools. Okay, and for the rest of your experience here, in your computer courses at least, all the professors are going to be assuming that you can use command line tools. So that's the fourth goal of this course, is to start getting to use editors and compilers and debuggers that use command line tools rather than using an integrated development environment. So questions about that? These are the four goals of this course. Okay. So, the website for the course, very important, worth writing down, web.eecs.utk.edu/BVZ/CS140. Okay, I sent that out also in a Blackboard announcement. Did everyone get that Blackboard announcement? Yes? Very good. Okay, so most of the announcements in this class will actually not go out through Blackboard. Instead, so let's get back to the main page here. So the main page has where to find things. And one of the things that you're going to be introduced to is a discussion board site called Piazza. Piazza is a great place for posting questions, getting answers, and we use it for this course also to make announcements. So if you did not register yesterday in lab because, for example, you were not there, you need to do so. There's a sign-up link, and there is then the actual home where you will go to Q&A, and there you'll be able to post questions about the lab assignments, about exams, about material that was presented in class, and we can answer those questions for you. Okay, it is also where I will be making announcements. Okay, sometimes I may make a Blackboard announcement, but in general it will be on Piazza that I make these announcements. So that is where discussion will be in this course. The reason I like Piazza rather than having you send me email or the TA's email is that we often get the same questions, and I don't want Alan answering a question differently than me, because then when you submit a lab we get a difference of interpretation and it causes problems. When you post your questions to Piazza, then they get answered, and it makes sure that the TAs and me are all on the same page about the way a question is getting answered. It also means there's a good chance your question will get answered more quickly, either because a TA or me sees it or someone in this class sees it. So I strongly encourage all of you to also post answers if you know it. Okay, at the end of the semester, when I am adjusting borderline grades, one of the big things I'll be considering is, did you participate on Piazza or did you not? Okay, so we strongly encourage you all, if you can answer a question, to go ahead and do so. Okay, so I'll circle back to Piazza in a moment. Just wanted to introduce that. So coming back to the website, you see that there's course information, there's pointer to the lecture notes, pointer to Piazza, pointer to the labs, which you looked at yesterday, pointer to top coder problems, which I'll talk about in a moment, a pointer to exams, which I need to still put up there, but that will be a pointer to actually sample exams that Dr. Plank has given, because I've not taught this course for about 5 years, and the last time I taught it was in C, and it's been slightly reorganized, so my old exams aren't really indicative of the kinds of questions you'll get. So I will give some sample exams that Dr. Plank has given in the past, and also as the exams get given, they'll be posted there with solutions. And finally, TA information that will include the TA contact information and office hours. We don't have that yet simply because the TAs haven't yet set up their office hours, but we will get that information posted. Okay, so let's just go through a few of the things. So the course information, my information, I reside in MinCal 312. My office hours are on, I'm going to actually probably have my office hours Monday from 2 to 4 because the assignments are going to be Tuesdays from Tuesdays at 11:59 p.m. So even though here you see the office hours Wednesday 2 to 4, I anticipate actually having my office hours Monday from 2 to 4 because I think you're more likely to come to me the day before an assignment is due than the day after an assignment is due. So it'll probably be Monday 2 to 4. Then the textbook for the course is Goodrich et al., 2nd edition, and I will be posting chapters to go along with the lecture notes so that you can read along. In general, I find that the book is a good reference source. I think that the lecture notes tend to be pretty self-explanatory, but it's often helpful to do a quick read through the book as well to reinforce things. The lecture notes often amplify on things, so as I say, it's good to often take a quick look through the textbook as well as the notes. When you come to class, what I expect you to have looked at is the lecture notes, not the book. So the book's a good reference and something you should look at, but it's not necessarily something that you would look at before class. Okay, and most of you know this. You probably can get it on Amazon for less than the university bookstore, but they often run out of copies on Amazon. Okay, another thing that I'm sure many of you care about, grading for the course. So the exams are 75% of the grade with 2 midterms and a final, accounting for 25% each. Lab participation is 5%. This means completing top coder problems in lab. Again, I haven't talked yet about top coder, but we will. And the labs themselves, the programming assignments that you'll be doing, are going to be worth 20%. So lab participation means you show up in lab, you make a solid attempt to do the problems that we give you in lab, and those problems stay in lab. Okay, so you're done when you walk out. The programming assignments, those are the things on the lab link, and those are worth 20%. Roughly speaking, the grading scale is the one that you typically have here at UT, but I also give pluses and minuses. I sometimes curve the letter grades, especially because in this course, the exams are not the multiple choice exams that you had in 102, but they actually involve you to work problems. Oftentimes here, you will not finish exams. In 102, you walked out often after 30 or 40 minutes. You probably felt good about your ability to finish the exam in the specified period of time. Here, that will probably not happen. Many of you may not finish the exams because they involve more programming. You're probably going to have to do it on paper and pencil rather than in front of a computer. We curve them so that we know that happens. We're interested in how much you have learned. Just saying, it may come as a shock to many of you when you find you can't complete the entirety of an exam. It's okay. Okay? People program at much different speeds. Some people are lickety-split. Some people take more time. Okay? So you're going to have to get used to the fact as you go on in your computer science career or in your computer engineering career that you may not be able to finish exams all the time. It's not the end of the world. Okay? So, telling you that up front. I'll tell you that again before we get to the exams. Okay, not going to go over missed exams right now. Hopefully that will not apply to you, but if it gets to that point, we will discuss it. Okay, lecture notes. I haven't finished going through all of it yet. You have the lecture notes, but I have not yet assigned textbooks readings with those lecture notes, and I have not yet put dates next to them either. Okay, I may not end up putting dates next to them, but I'm certainly going to put next to them places in the textbook where you can find out the information associated with that lecture. Also, I will be posting video lectures of what I have talked about in class. So I use Camtasia. That's what this little red thing is. So right now I'm actually recording this lecture. So after each lecture, within a day, I've typically uploaded it and put it out on YouTube. And so here you will also see about a day after the lecture, you will see a link to that lecture. Now, you may think, great, I can just skip class and look at the lecture. That's going to really hurt you. Because as I said, we do hands-on stuff in this lecture. There's going to be a lot of times during the lecture video where you hear crickets. Okay, because I'm going to be having assigned a problem. You all are going to be working on it here in class. Alan and I are going to be circulating and helping you to solve it. And if you're trying to follow along on the online video, well, crickets. Okay, so it really is going to have a lot of value if you can actually come to class and do the problems and engage in the discussions that we'll be having. At any rate, if you click on a link, you can see what is you can see what it is. You can see it's not often a huge amount of material to go through. Okay, it's not going to break the bank. And you don't have to look at the programs in a huge amount of detail. It helps to look at them some, but that's part of what lecture and going over things are. But I do expect you to look at the pros. Okay, then we already went through Piazza. The labs, the lab assignments, the way things work, they're they're almost always due on Tuesdays, except around spring break. And you'll see also the first quasi, not this week, but next week you'll be doing 2 labs. The first lab, lab 0.5, you'll be doing in lab. And quite frankly, you should be able to finish it in lab. And then lab 1 is what you'll be doing outside of lab. So that's one of those that's due on Friday. The other is occurring right around, I believe, an exam. Actually, also to break up 2 multi-week labs. Otherwise, they're due on Tuesday at 11:59 p.m. And you have a grace period, not a grace period. You have up to 2 days to hand it in late. Okay? Or did I say 3? Sorry, I'm teaching 2 classes, and I think I may have, what did I say about lateness? 3 days. Okay, 3 days in here. So you have 3 days, but each day you hand it in late is 10 additional points off. So if you hand it in 1 day late, you only get up to 90 points, 2 days late, 80, 3 days late, 70. The way I've set it up is that there are 1,200 points available. 50 points for lab 0, 50 points for 0.5, 100 points for the remaining labs. So there's 1,200 points available to you. I'm going to make your grade be out of 1,100. So if you do all the labs and get a perfect score, it would actually be 1,200 divided by 1,100, and you would actually score over 100%. But what that's meant to do is to give you 1 free lab. That can either be an extra credit lab for you if you do a lab poorly, or things happen during the semester. You catch the flu. Okay? You break a leg. Your grandmother passes away. You just get super busy. 3 midterms or 4 midterms show up on the same week. Okay? Stuff happens. This is designed to give you that flexibility when something happens, because inevitably stuff does happen during the semester. So you get that free lab. But for that reason, Hard Heart is not going to be happy when you say, can I have an extension? The answer is no, because Hard Heart already put in place an extra lab for you to account for this situation. Okay? So Please do not ask for extensions. The answer will be no. Okay, by the same token, please try to get started on the labs early. I know this is a futile plea in most cases, but a lot of the problems where I get emails that ask for extensions start with, my dog got sick Tuesday morning. And my first thought is, great, there were 6 days for you to do that lab before Tuesday morning. How come you started it Tuesday morning? Okay, I know why, because you have other deadlines. But the point is, we give you a week to work on the labs, not a day. And so, try to get started on them early because stuff does happen unexpectedly on the last day where you may not be able to do it. So if that happens, just, accept the fact you may be handing it in late and you'll be getting 10 or 20 points off. Okay, lab submission information. I know that I'd said submit your code on Blackboard, but we talked about it in our TA meeting yesterday. And after this lab you will be submitting using Blackboard. But after this first lab, Lab 0, you will be submitting using a 140 submit script, which we will go over in lab next Wednesday. So just a reminder for both of us, Alan. So we'll go over how to submit your labs using that script on Wednesday. For this first lab, Lab 0, that's due Tuesday night, you will submit using Blackboard. Okay, lab grading. Your lab grade is determined as follows. 80% is correctness. 20% is commenting and programming style. Correctness. We are using so-called grading scripts for this course. So Dr. Plank actually came up with, for each lab, 100 test cases. And what happens is your program is run against those 100 test cases and compared with his output. For each test case that you get correct, you get 1 point. So if you get 90 test cases correct out of 100, you get 90 points for your correctness grade. So 90% of 80 would be 72. Yes. The test cases are public information. So with each lab, it shows where you can get access to those test cases. You're also able to run the test scripts yourself. So when you submit the lab, you should already know what your correctness score is. So there's no information held back here. The testing scripts are available. The test cases are available. You can run them. You can look at the output from both the expected output and your output to see what the differences are, and you can fix it. That's nice. The downside of it is that your output has to exactly match the output that we expect. So there's no room for creativity in your output in this course. When we tell you that there is 5 spaces between 2 fields, by gosh, there better be 5 spaces between those 2 fields, or else you'll be getting absolutely zippo credit for the assignment. So there's an upside to it, there's a downside to it. Okay? The other 20% is your commenting and program style. I have given you 3 different treatises to read. They're not long, but you should read each of them because it tells you how we like you to create your programs in this course. Writing a program is a lot like writing an English essay. You can organize it well or you can organize it poorly. We obviously prefer that you organize it well so that it is easy to read, so that someone else looking at your code can easily understand it. In this course, that person is a TA. In the real world, that person may be your boss or someone who's maintaining your code. So it is much better to write a clean, elegant program than it is to write a sloppy, inelegant one. And these 3 articles down here give you an idea of how to do that. Okay, so one was written by a person at Northwestern and modified by one of our professors, Dr. Parker, and really does go into some nice analogies between writing an essay and writing a program. There is Commenting Your Code by the inimitable Dr. Plank, just showing you an example. And then there are Writing Clean Code by me. A lot of my thing is some of my pet peeves. Okay, I will tell you right now that my biggest pet peeve is well-chosen variable names. I will tell you right off the top that I hate variable names like A, B, C, which is a lot of what I see in programs. Okay, I understand that they're short to type. Okay, someone trying to maintain your code or read your code is not going to have any clue as to what A, B, and C mean. Okay, unfortunately, a lot of the code you see, both in textbooks and elsewhere, use A, B, C, X, Y, and other one-letter abbreviations, thus leading you to think you can do the same thing. You can't unless you want to get bad scores on your commenting and program style. Okay, so just as an example, here is a classic swap. Okay, and it's fine with A and B. I'm not going to get into it here, but my beef here is with temp. Okay, temp. Well, that's great. It's a temporary variable. Duh! I see that. Exactly what does temp do? It saves A. Well, perhaps we could say save A then as the variable name rather than temp. Wouldn't save A make a lot more sense to someone reading your program? I think so. If I was reading your program and someone declared temp as save A, it would make a lot more sense what the heck that variable was doing. Then I wouldn't even have to comment it. Okay, whereas if I declare temp, I probably should put a comment next to it that says saves the value of A. Okay, so if you use meaningful variable names, you shouldn't have to comment them and say what they mean. So that's my big peeve. The only time I really am comfortable with single letter variable names is with loop subscripts, because that's so generic in computer science. But even there, if you can come up with a better name, please do. So for example, if you're iterating through something like those PGM files from CS102, where it's a table with rows and columns, why not just say for row equals 0, row less than max row, and for column equals 0, rather than saying for I equals 0 and for j equals 0. So much more understandable to someone reading your code when you say for row and for column. Okay? They'll have a much better idea of what you're doing. Okay? So please use well-chosen variable names. Do not use A, B, C, D unless you want to receive a big fat deduction on your labs, in which case, go right ahead. Okay, so it has some other things in there, but I just did want to talk about that. Well, we'll get to that with Boolean. No, I will get to that now. The other thing, in your code, use Booleans for flags. Okay? If you have to keep track of something, use a Boolean. That's what it's there for. Now, I know that in Dr. Plank's notes, he uses integers. He's old school. He came up through C, and in C, they don't have the Boolean data type, and so you had to use integers. Okay? But in C++, bools are there for a purpose. They are there for setting flags. If you need to keep track of a true-false condition, use Booleans. They often take up less space. They are often more efficient, and you are guaranteed that you won't be able to often use them in a non-Boolean expression. So please get in the habit of using Booleans for flags rather than using ints. That's what they're there for. Okay? So I guess that's my other pet peeve. Okay. Late labs, we've gone over that. Plagiarism policy. So, on your labs, you are expected to work by yourselves. You will hand in code that is your own. You will not hand in code that you worked on with someone else. If you do, that's considered plagiarism, and your punishment may range anywhere from a 0 on that lab to an F in the course. Now, it is okay to talk about the lab with other students, but just at a high level of how to solve it, not at the point of we're sitting down together and typing code. That is a no-no. Okay? Also, it is fine for you to ask the TAs for help, to ask me for help. It is fine and encouraged for you to post questions to Piazza. Okay? However, with the exception of Piazza, I consider it cheating for you to put any query about the assignment on the internet. Okay? It is very easy for me to do a search of the internet looking for keywords in a lab. Okay? If I find that, then you get an F for the course. That is how serious I consider that instance of cheating. So do not post it to discussion boards. Do not post it to professional services. If we catch you doing that, it will be an F. And I may well consider also referring it to Student Judicial Affairs. I really detest that. So if you have a question, ask the TAs, ask me, post it to Piazza. That's what we're here for. Okay? Yesterday in lab, correct, Alan, you all went over this change mod, creating a directory and making sure that. Excellent. So hopefully you in lab yesterday already did this with setting up your directory so that no one can look at it. Okay? So that's the other thing is if I get a lab and it's a copy of your lab and you come to me and say, I have no idea how such and such got their hands on my code. Well, probably you left your lab unprotected in some way, or you actually did let them have the code. The point is, I don't know how they got their hands on your code. Okay? I have to assume the worst, which is you gave it to them. So please make sure that you protect yourself and that you keep your directories protected. And the way you did that, you did it in lab yesterday. You set the permissions so that the no one can get access to it. Alan, yesterday, did you actually go over what the meaning of each of these bits is so they know what the 0 and the 1 and the 7 mean? Okay, we may go over that again then, just so that you all know what's going on. Okay, so that is that. Now, in the labs, you are going to be working on, you will often be working with a partner in lab. So that is fine. And on the top coder problems, which we will get to in a moment. Okay? So on that, you will often have a partner. But for the lab assignments, the programming assignments, you need to do them by yourself. And then at the bottom, again, the commenting and program style. Okay. That brings us to top coder problems. So yesterday, you went and actually signed up for a top coder account. Top coder is a website that it does many things. I believe it was actually designed to put programmers in contact with people desiring programming help, i.e. it's a glorified placement agency. However, it is a, shall we say, different kind of placement agency. One thing it has is competitions where you can pit your programming acumen against people's programming acumen from all over the world. Okay? this can either pump up your ego or be very deflating to it. Typically, it's very deflating to it because you'll be going up against the very best from all over the world. Okay? But they often have nice, challenging problems on Top Coder, and you will not actually be engaging in the competitions, but you will be in lab doing many of the programs that they have posted there. So they have an editor there, they have a way to compile programs, a way to test them, and we'll be going all through that in another week or so. This lab and the lab on Wednesday, you won't be doing Top Coder. You won't start your Top Coder problems until the lab on the 21st. But for the rest of the semester, basically what will be happening in labs is you'll have 2 Top Coder questions, and for roughly the first 60 minutes, you'll work on those Top Coder questions. Many of you will not completely finish them. Okay, the point is simply to get you started working on them, and they'll typically cover material we went over in class, and they're designed to do 2 things. First of all, they're designed to give you practice with problem solving. Okay, in CS102, we often just gave you the answer and then expected you to code it up. Okay, but in fact, programming typically involves 2 things. First of all, figuring out how to solve the problem, and then once you have figured out how to solve the problem, coding up the solution. Okay, the Top Coder problems are going to be your first real introduction to having to try to figure out how to solve the problem. And then the second part is giving you more practice with writing code. Remember the first thing we said, goal of this course, becoming self-sufficient C++ programmers. So the second part, getting practice with coding things up using C++. Typically, the problems involve the data structures that we've talked about in the last week or 2 of class. Okay? So, in the labs, on those Top Coder problems, you have the option of working on it by yourself, but you also have the option of working on it with a partner. And I strongly encourage that. There's a lot of literature on so-called pair programming, where people work together on a problem in front of a computer at the same time, and a lot of positive results from those experiments showing that typically you code more quickly in that situation, you discover bugs more quickly, both of you come up with a much better comprehension of the problem and its solution. Now, I know a lot of you prefer to work alone. That's fine. You can work alone in lab, or you can work with a partner on those Top Coder problems. Okay? As I said, we know that oftentimes you will not finish them. That's not important. The important thing is that you tried. As long as you tried and gave it the good old college effort, you will get full credit for that day in lab. Okay? So typically the first half of the lab, the first hour will be on Top Coder. The second half will be on whatever programming problem has been assigned that week, with typically the TAs going over the problem, giving you hints on how to do it, and then perhaps if there's time, turning you loose at the very end to start doing the lab. Okay. Finally, the exams, as I said, there's going to be 2 midterms. I haven't yet decided on exactly when those midterms will be. I will decide that within the next week, get that posted, plus the final. As I said, the exams, they're going to be more along the lines of your solving problems, not the multiple choice questions that you had in 102. Plus, this time, most likely, you will be writing out programs by hand on the exam rather than doing it using Code Assessor. So, that pretty much covers the basics of things. Any questions?
Is there a programming clinic for CS140?
Yes, thank you. There is a programming clinic for CS140. And as with 102, I'm going to try to get most of the hours on Monday and Tuesday, since the labs are due on Tuesday. And then just like 102, there's going to be office hours on Thursday and Friday. Now, for the most part, the programming clinic and the office hours are going to be undergraduate TAs. So your lab TAs will be there Wednesday, and you're always free to ask for help using Piazza, or if you have to, you can make an appointment with them. But the undergraduates will be handling the programming clinic and handling office hours. And I'm having a meeting with them tomorrow, so we'll get that stuff set up. And when we get it set up, it will be under TA information. Okay? Other questions? Okay, I guess actually that leads me to another thing, which is on Thursday and Friday, those are days where there's not as much activity. So I know that's when you typically have just finished a lab and may not be as excited about starting it. But if you are struggling in the course, Thursday and Friday are the days when you should be going to talk to the TAs. Those are the days when they can give you more tutoring assistance. I often get questions from a number of students saying, can you suggest a tutor? And my first reaction is always yes. Go to the free TA office hours on Thursday and Friday. TAs often say we are the lonely Maytag repair people, for those of you who have seen those ads. Okay? They're there to help you and they're free. Okay? So you should take advantage of that. Do not get behind in this course. You will not catch up. Okay? This course goes at a faster pace than 102. I know the first couple weeks it will not seem that way because we'll be doing a little review. That's because many of you took 160 before you took 140. You didn't do a lot of programming in 160. So the first couple weeks may go a little bit slowly, but then we ramp up quickly. And if you fall behind, you will be toast. Okay? So if you find yourself struggling with material, go to those office hours on Thursday and Friday. The TAs can give you a lot of one-on-one attention on those days. On Monday and Tuesday, it's much more chaotic. The assignments due Tuesday night. People are trying to get their labs done. A lot of people show up, especially on Tuesday. You can't expect to get very much one-on-one assistance on those days. There is going to be more, here's help with debugging your program, help getting it to compile. There's not going to be a lot of, gee, I didn't understand this thing about hash tables. Could you please explain it to me? Or I really don't know how to get started on this lab. Could you please help me? Okay, the TAs just aren't going to have time to do that on Monday and Tuesday. So your time for getting help is on Thursday and Friday. Okay, the other thing I wanted that just occurred to me, starting in the fall, 160 is a prerequisite for 140. And we've done our best to try to get students to take 160 prior to 140. If you have not yet taken 160, you are going to be at a slight disadvantage in this course because 160 goes over things like numeric-based systems and things like assembly language that would help a lot in this course. Okay? It's not to say you can't succeed in this course without taking 160, but you are going to have to work harder if you've not had 160 before taking this class. Okay? So, not saying, as I said, I'm not saying you can't succeed. You certainly can, but you're going to have to work harder at it because there are concepts presented in 160 that would help you in this class. Okay. A lot of it has to do with things like hexadecimal and octal, with pointers, and with recursion. Okay. But when we get to those things, those of you who have taken 160 will perhaps see what I mean. And as I say, you can pick it up without 160, but you may find yourself on those topics having to work a little harder. You may have to go and see the TAs on that to get a little extra assistance. Okay, other questions? Okay, so let's just quickly, we have about 20 minutes, go over, I know some of this might, Alan, just quickly, did you go over G++ yesterday? Yeah. Okay. Did you go over SIGWIM?
No.
Okay. So you just kind of...
We told them that we would be talking about, we said what SSHing was, and
Okay, so we'll do that a little bit now too, as well as having you do that in labs next week. Okay, so as I said, in this course, you're going to be using command line tools. And it would help if some of these tools were loaded on your laptops. I actually would like it if you would try to bring your laptops to class with you if you have them. Otherwise, you can certainly look over a neighbor's shoulder, because we will be doing some stuff in this class with hands-on exercises that would require you to use a laptop. Now, there are two ways that you can use your laptop. As Alan was just saying, you can secure shell into the Hydra machines. And in lab on Wednesday, we'll be going over specifically how to do that. The other way is you can actually download stuff onto your computer that will allow you to do work locally on your computer. Now, if you do work locally on your computer, please make sure that before you submit a lab that you have run it on the Hydra labs. Now, you almost certainly should have done that, because you'll be using Dr. Planck's grading scripts to make sure whether your program was absolutely correct or not. And his grading scripts only run on Hydra. But it's certainly the case. I have a Mac, and I know that sometimes programs that run on my Mac don't run on the Hydra machines. Okay? Some of that is because sometimes there's a little bit of difference in the implementation. Okay, well, that's always because there's a little bit of difference in the implementation. There are ambiguities in the C++ standard, and the implementers of compilers sometimes interpret the standard differently. One of the big differences is whether or not you assign a value to an uninitialized variable. So if I have int min, the standard is silent as to what you do in this case. Actually, the standard is not silent. The standard is you should assume the variable's value is uninitialized and has no, it's an undefined value. It's whatever is there before. However, some compiler writers will assign a default value to an uninitialized variable. Okay? Our Hydra machines do not do that. They leave the variable uninitialized. However, it appears that my Macintosh assigns a value of 0 to an uninitialized variable. So if I forget to initialize a variable on my Mac, it will conveniently initialize it to 0, and many of my programs work that do not work properly when I port it over to the Hydra machine. So that's just one example of a different interpretation in the standard that causes different behavior on a Macintosh versus on Hydra. Okay, so always important if you have done your work on your Windows laptop or your Mac laptop to then port it over to the Hydra machine. Make sure it works there before you submit it, because that's where it will be tested. Okay, so if you have a Mac, congratulations. First of all, you have the prince of laptops. Okay, like Dr. Planck, I don't think much of the Windows operating system, so I love my Mac because it runs on top of Unix. However, if you have a Windows box, never fear. Despite its every effort to impede you in getting your programs successfully completed, you still can make it happen. Don't worry, just joking. I do like to make some cracks about Windows machines. Just so you know, my wife is also a PhD in computer science, loves Windows machines, loves to make cracks about Macintoshes. Whenever I get the spinning rainbow wheel of death on my Macintosh, she laughs and talks about how that would never happen on a Windows box. So she happens to think that getting stuff done on a Mac is every bit as cumbersome as I think it is to get stuff done on a Windows machine. So please take my cracks about Windows machines in good humor. There are many people who think that Windows boxes are preferable to Macintosh boxes, including my wife. Okay, but if you do, that said, if you do have a Macintosh, it is true that it already has Unix preloaded on it. If you just go, if you have a Macintosh right now, you can actually follow along with me on this. Go to your Finder window, and you'll see something called Applications. Click on that and go down to Utilities, okay, which will be at the bottom, and double click on it, and you will see in Utilities something called Terminal. Double click on that and it brings up a Unix window that you can type into. Okay, so on a Mac you already have access to a Unix terminal window. If you are on Windows, there is a way to get access to a terminal window, and it is through a company called Cygwin. Okay, so you can go to their website and they will allow you for free to download a Unix environment. If you have difficulty doing that, please go see the TAs during their office hours on Thursday and Friday, and they can help you with that. Okay? Don't do that on Monday and Tuesday unless you do it next week. Okay? Monday and Tuesday next week is not going to be very busy, so that's good time too. But you should try to get it downloaded as soon as you can. It's nice if you actually have Unix loaded on your machine, and Cygwin is an excellent program for doing that. Okay? It is, as I said, possible to secure shell remotely into the Hydra machines, either on your Mac or on a Windows box. With Windows, you typically would use a program like Putty, P-U-T-T-Y, which you can look up on the internet. Write it down here, Putty. It's just one of several programs that you can get for doing secure shell. If you also were to Google for Windows SSH secure shell programs, I'm sure that you would get a lot of hits. Okay, Putty just happens to be the one most commonly used. Also, I will make a post to Piazza. There is a page that tells you from our lab staff suggested programs that you can download to Windows. So I'll post a Piazza post after class today pointing you to that page. So in addition to that, it would be good if you would download the tools that we prefer you use for this course, VI and G++. So VI is the editor that you used yesterday. Actually, most of you will be using Vim, which is a more recent version of VI. As the lab notes say, I don't care if you use VI or if you use an editor of your choice. Many of you will like to use Pico. Some of you may want to use something like Notepad or WordPad. I don't really recommend that. I really do encourage you to try to start to use a command line oriented editor like VI or Pico. You'll see me sometimes using an editor called Emacs. Any of them are fine. You can download them for free. Same thing with G++. I believe that on the Macintoshes that it is already installed there for you. Okay, I'm going to have to check to see whether, Alan, you may know this. Do they need Xcode or not?
Yes.
Okay.
They'll need Xcode.
Okay.
We'll have to go through some rigmarole.
Okay, so if you have a Mac, and you did not get Xcode downloaded from 102, then you will need to download something called Xcode. So if you are on a Macintosh, so if you're on a Mac, you will need to download Xcode. Now, if you use that Mac in 102, you have already downloaded Xcode, and so it should be.
They can download it from the App Store. It's gotten really easy with the recent versions. But then the way it works now, it changes every few years. But the way it works now is then they're also going to have to install the command line tools, I think, through the terminal.
Okay.
And then you gotta run a terminal command to like sign the agreement.
Okay, we'll put up some notes.
It's not hard. It's just
I understand. We will put up some notes. Okay, so if you already did this as part of 102, then you're good. You have G++ already there. You may see something called Clang. It turns out that Apple has created its own version of a C++ compiler called Clang. However, Clang is alias to G++. So when you type G++, it invokes this Clang compiler, but in fact, it's very similar to G++. But that's where some of the differences do arise when you compile on a Mac and then you port it over to Hydra. Occasionally there are those slight differences because the people who wrote the Clang compiler made somewhat different interpretations on those ambiguous parts of the C++ standard. If you are on a Windows box, the best thing to do is to download MinGW. Is it 4.8 now that's the latest? Don't know. Okay. MinGW is typically the best if you just Google it, and again, we will put up some notes.
why would they need that if they're using Sigma?
Does that come with a G++ compiler?
When you install Sigma, there's a whole, it prompts you for a whole, it's got this whole thing like developer tools, office tools, internet
Okay.
tools, and you select which, and then you can expand each one and select which ones you want. So they should, I think, go to developer tools and make sure that the G++ and well, pretty much all of them are selected, and then go to editor tools and make sure them is selected. And I think that should, and there might be
Okay.
another one for SSH and SFTP.
We're going to have to put up
It's
some.
not hard. It's just
I understand.
it prompts you.
Okay. So maybe we won't put up notes. So when you download Sigwin,
But I don't see where MinGW would come into play since they're not doing code live.
okay. Which one did I get wrong? It's a 6. It is a 6-letter word. I thought it was a 5-letter word. Okay, so when you download Sigwin, okay, make sure that you select G++ and SSH when prompted to.
And
Pardon?
and them.
And Vim. G++ and SH and Vim. Okay. Xcode is not, I mean, I've been through that download procedure. I'm going to put up notes on that. That is not as simple. So I will put up notes on that. Okay. So bottom line, try to get a Unix environment working on your laptop with Vim or some comparable editor with G++ and with the ability to secure shell.
And if they really want to have fun and install VirtualBox, they can come to us and we'll be happy to.
Yes, so if you really want to have fun, as Alan says, implement a virtual program. We have virtual software that emulates virtual Windows things that you can download from our website, not necessarily our website, but they point you to it, but you have to come to the TAs for that. Okay, so went over VI in the labs. In this course, you will be using a command line interpreter, command line compiler to compile things. So, if you have a Macintosh right now, you should be able to do this, or if you happen to have a Unix environment already in place, you can follow along with me. So, you'll see that when you click on these programs, you can save them to your machine. Or it may pop up something that shows the actual program. Either way. But I'm going to save it to my machine, and I use Emacs. I do not use VI, so you have to get used to that. And I will save it to, and I'll leave it in my downloads directory for the time being. But, can you all read this in the back? Excellent. Okay. So, CD stands for change directory, so I'm changing to my downloads directory. That's not normally where I would keep my file. Normally I'd put it in the CS directory, but for the time being I will. G++ is the compiler command, and you can try this, as I said, if you're doing this on a Mac, you can do this along with me. If you just type G++ and then the name of your C++ file, it will go ahead and compile it. Usually the first time it will sit there for a little while. And you can see that there was an error generated. Okay? So, does anyone know, looking at this error message, what happened? There is no type. What should be in front of main? Int. So in fact, I'd be interested to see whether this program compiles on the Hydra machines. It may or may not. I'm not going to give it a try right now. But old-style C programs did not require a type. And Dr. Planck's notes, it appears that that is the case. He did not do it. However, the implementers of Clang are being very picky, and they're adhering to the C++ standard, which says that main must have int. Okay, so we'll do it again. Rerun the compilation. Now, you may have seen me, I went bang G. A lot of Unix things have a convenient history mechanism where they remember your previous commands. If you actually type history, it will give you a list of the previous commands that you executed, which can be very handy. So that rather than having to completely retype the previous command, you can either type something like, I call it the bang, it's exclamation points, so 538, and now it will re-execute that command. Or if I type the first part of what I did, it will search back through the history looking for the first command that matches the start of that pattern, which is G++. So you may see me do that a lot. That's what I'm doing. Okay, so it compiled, and it compiles it into something called a.out. File that again is just from when C was developed in the 1980s. The developers said if you didn't specify a destination file, it went to something called a.out. To execute it, if you just type a.out, you will get something that looks like this that says command not found. Okay, so you need to put a dot, which is a period and a slash in front of it. Okay, that says to look in the current directory. Okay, as we go along, you'll get some more, but dot and a slash and then a.out, and it executes. Okay, now just a couple things. I would prefer you not use exit in this case. Okay? Typically better is to say return 0. Exit, I'll talk about it next time. There's some subtle issues with using exit in a program. Okay, so I prefer that you use return 0. Typically, you will want your file, hold on for 1 minute and I'll let you go. You do not want your file to be put in a.out. You would like it typically to be placed in a file with the same name as your program. So it was called homework.cpp. We typically want to put the executable into a file with a similar name, namely homework, that has no suffix. The way we do that is we can pass parameters or arguments to the compiler, and we do that with so-called flags. So -O is a flag that says to put the output from the compiler into a file called homework. So the executable is now put into a file called homework, or HW, rather than into a.out. So flags in Unix typically start with a dash and then the letter for the flag. So the dash makes it clear that it is a flag. And again, if I now type ./HW, the program runs. Okay? So, your, quote, homework for Tuesday is to try to repeat this on your own. Okay? So see if you can't get Cygwin downloaded to your machine, or if you Xcode, and try to do this yourself. Make sure you can do it when you come to class on Tuesday, because on Tuesday I'm going to expect you to start being able to do this in class. Okay? So, little homework to finish. And I will get this video lecture up within a day, so you can also kind of follow along if you need some help with it.